This morning, on December 30th, the tracking stations near the equator noticed something subtle, but deeply unsettling. 3I Atlas, the third confirmed interstellar object ever recorded, is not just continuing its trajectory, it's changing it. Again. But this time, not because of the sun, not because of gravitational forces or radiation pressure. It's responding to nothing, or rather, to something we don't yet understand. What we're seeing right now is behavior that challenges every model we've built to explain how interstellar objects interact with their environment. Because this isn't random drift. This is patterned, timed, structured, and it's happening now. For nearly 72 hours the object did nothing. That's what made it so disturbing. 3I Atlas. Once the subject of global fascination, once the source of non-gravitational anomalies, reflective pulses and strange anti-solar jetting, had entered a rare state of stillness. Observatories across 5 continents had logged the same numbers. Stable light curve, no measurable change in spin, no coma variation, no new jet formation. Even amateur astronomers, monitoring the object from backyard telescopes, noted how quiet it had become. The chatter online was simple. Maybe the show was over. That stillness wasn't normal, not for a comet, not for an object that had already demonstrated dynamic venting, unexplainable orientation shifts, and electromagnetic responses that didn't match its environment. Stability, in this case, wasn't peaceful, it was a warning. A silence with tension under the surface, the kind you feel before a fault line gives way. Then, in the early hours of December the 30th, that silence broke. The first to notice were spectropolarimetric instruments in northern Chile. While conducting routine calibration runs, the team at Cerro Pachon Observatory observed a minor negative polarization spike, a rapid dip, brief and sharp. Negative polarization in itself isn't rare. It occurs when light scatters off surfaces that are smooth, compact or metallic. But the timing was what mattered. For 72 hours, the polarization pattern had held flat, positive, predictable. Then, within the span of 16 minutes, it dipped into the negative and stayed there for over an hour. That was the first crack. 3 hours later, the European Southern Observatory's wide-angle photometry array detected a slight shift in the light curve. Not chaotic, not noisy, but deliberate. A clean deviation of 0.13 magnitude. The shape of the curve was wrong. It wasn't the kind of asymmetrical spike you'd expect from venting or rotation. There was no corresponding burst in brightness, no tail activity, no new coma layer. The shape was geometric, even. An hour after that, JPL's tracking solution showed a fractional drift in trajectory, less than 1/10 of a degree, but away from all gravitational baselines. The object, by all measures, had moved. It had adjusted. Again. But this time, not in response to the sun, not from a CME, not from solar wind. It moved in silence. What makes this behavior so difficult to explain isn't the anomaly itself. Comets have outbursts. They shift, they vent, they fracture. But those events leave signatures, thermal noise, chemical traces, rotational torque. This didn't. This one left a clean signature, a fingerprint with no hand. For planetary scientists, that's worse than noise. It's controlled. When light scatters without turbulence, when a mass moves without a push, when an object realigns itself to a vector where no force exists, the most unsettling explanation is not chaos, it's intention. And if not intention, then design. No one's saying it's artificial. Not yet. But what we saw on the morning of December 30th wasn't just a wake-up from dormancy. It wasn't just a return to activity. It was precise, ordered, and above all, timed. It was as if 3I Atlas had been waiting, and now it wasn't. The silence is over, the pattern is back, and what follows may not resemble anything we've seen in this solar system before. When astronomers talk about trajectories, they speak in absolutes. Space is ruled by math. Gravity draws its lines, radiation pushes subtly, and momentum, once established, obeys until something interrupts it. That's what made the morning vector shift so unnerving. It wasn't expected, it wasn't chaotic, and it wasn't explainable. At exactly 0507 UTC, multiple ground-based telescopes in the Canary Islands and Hawaii registered a revised path for 3I Atlas. The difference wasn't large. In fact, it was barely within the margin of observable deviation. But as the hours passed and the position was cross-referenced against ESA's solar orbiter, the deviation became undeniable. 3I Atlas had shifted, not randomly, not in a curved deflection like from solar radiation pressure, but in a linear redirection, a path slightly off-axis from the original escape corridor. The new heading tilted approximately 0.0116 degrees inward toward the heliocentric plane, with velocity still increasing subtly along that revised vector. It shouldn't have happened, not this late, not in this region of space. By this point in its journey, 3I Atlas had already completed its solar encounter. It had left perihelion behind. The major gravitational players, the Sun, the inner planets, were already trailing in its wake. It was outbound, coasting, or at least it should have been. But now something had acted upon it, or something internal had changed. The usual suspects were ruled out in minutes. There were no new jets observed, no surface flaring, no sudden ejection of material. The coma remained tight, and spectrometry showed no increase in volatiles that might indicate fresh activity. The solar wind was moderate and stable, and there were no recent coronal mass ejections. Even the background magnetic field was calm, yet the object moved. Orbital scientists at JPL attempted to simulate the new path using standard outgassing models, the same kinds that explain subtle thrust from sublimating ices. But none of the models fit. The amount of deviation required more than a simple jet. It required coherence, either a sustained directional release or an applied force, and this was no spiral or tumble. The motion was consistent over hours. When the ESA rechecked their interferometry data, they found something more. The object's axis of rotation had not changed. There was no torque, no detectable spin-up, no sign of chaotic venting. Something had nudged the object without pushing it off balance. That's a problem. Because in known comet physics, directional force always creates rotation. Ice jets don't act like gentle engines. They stutter, they hiss, they wobble the body they push from. But this wasn't wobble. This was glide. Even stranger, the new vector doesn't intersect anything. If the object were being drawn, say by a planetary gravity well, or pulled into alignment with another body, the new trajectory would eventually lead somewhere observable. But as of this morning, the line points into a corridor of deep space with no known body, no gravitational anchor, no target. That kind of movement suggests purpose, or precision, or a feedback mechanism that we don't yet understand. Some theorists are beginning to whisper about resonance, not in sound but in geometry, that the object may be aligning not with mass but with fields, magnetic. Electromagnetic, possibly even directional vectors from solar wind gradients. But there's no precedent. No comet has ever done this. No interstellar body has shifted its heading like this, not without external pressure, and certainly not without signs of internal disruption. And that's the heart of the mystery. It moved, but left no mark, shifted, but left no wake. And now it travels on a path that we didn't calculate, towards something we haven't yet found. The pattern returned quietly, almost too quietly. In the early afternoon hours of December the 30th, a narrow-band ultraviolet observatory positioned near the South Pole began transmitting preliminary data back to the European Space Agency. It was routine, a daily slice of the spectral profile surrounding 3I Atlas, intended to measure the usual coma behavior, light scattering properties, and emissions from sublimating volatiles. But within the third frame, something stood out. There was a filament, a coherent narrow stream of energized particles stretching directly back toward the sun, not outward, not flared, not deflected by solar wind, but pointed back along the solar axis like a tether. It wasn't the first time this had been seen. In early November, just days after perihelion, amateur astrophotographers began sharing images of what looked like a reverse jet, a structure emerging from the nucleus but oriented in the wrong direction. Most dismissed it as an optical illusion. A dust plane caught at the wrong angle, a trick of viewing geometry. After all, real jets, those caused by sublimating gases escaping through vents, should always be pushed away from the sun, not toward it. But now it was happening again, and this time, it wasn't an illusion. The high-resolution composite from the ultraviolet array revealed a distinct stream of ionized material, trailing in the anti-logical direction. Measured at an angle of roughly 106 degrees relative to solar centerline, it mirrored the exact orientation of the November anomaly. In fact, when overlaid, the structure aligned within a margin of error less than 0.3 degrees, which means it wasn't random. The behavior of comet jets is generally dictated by sunlight. The solar radiation heats the sun-facing side of the comet, causing ice to sublimate, gas to escape, and dust to be dragged with it. This material expands outward, forming a coma and eventually tails. One tail typically bends due to orbital motion and gravity, the dust tail. The other, the ion tail, streams directly away from the sun under the influence of solar wind. But this wasn't a tail. It wasn't a curved feature. It wasn't made of diffuse dust being blown backwards by motion. This was a jet, a focused stream, aligned tightly, narrow in width, and low in dispersion. It didn't curve, it didn't flutter, it didn't break up into a fan. It aimed, and it aimed toward the sun. The possibility that this is just a natural vent is not impossible, but it defies how pressure gradients work. Ejecting gas directly toward the sun requires the source of that pressure to originate from the opposite side, or more strangely from an internal reservoir that is purposefully channeled. To do that without destabilizing the nucleus, without producing torque, without causing rotation. It suggests either extraordinary material cohesion or design. What's more unsettling is that the brightness of this anti-solar jet wasn't erratic. Its intensity fluctuated with the solar flux. Not exactly, but enough to track the rise and fall of solar output with suspicious consistency. Some scientists began using a term they hadn't dared apply before: feedback. Not random emission, not chaotic venting, but a structured response, the kind of pattern that implies some form of interaction. Either something within 3I Atlas is adapting to its environment, or it is aware of that environment in ways we've never seen from any natural body. When a jet aims for the very source that should be pushing it back, when that jet returns weeks later at the same angle, under the same conditions, when it repeats, it's no longer an anomaly. It's a message. The question is, are we ready to read it? At first glance, there was nothing there. By early evening on December the 30th, optical images from the Canada-France-Hawaii telescope showed 3I Atlas as a dim, compact object, nearly point-like in its visual profile. For a comet, that's already strange. Even at this stage in its journey, well past perihelion, most active comets still display a visible coma, a trailing tail, and some evidence of interaction with solar wind. But the images returned nothing dramatic. No extended structures, no diffuse light, just a steady central brightness with minimal halo. To the casual observer, it looked inert, but that conclusion didn't hold for long, because while the visible light faded, the signal in other wavelengths didn't. At 19:12 UTC, the Meerkat radio telescope array in South Africa, operating on a rotational sky scan, passed over 3I Atlas's predicted location. It wasn't even a scheduled observation. The object had drifted off the list of high-priority targets for that day. The scan was routine, passive, but what it picked up changed everything. A sharp emission spike, narrowband, stable, and repeating every 5.8 seconds, cut through the baseline signal. It lasted only 90 seconds, then it vanished. And just like that, the conversation changed. What Meerkat captured wasn't noise. It wasn't random interference or background static from the Milky Way. The pulse stood out clearly from cosmic radio fog. It occupied a narrow band in the megahertz range, far below where thermal plasma emissions usually manifest, and it repeated in clean intervals. 6 pulses, each separated by exactly 5.8 seconds, each identical in strength and duration. Radio observatories are used to anomalies. The sky is full of them. Pulsars, quasars, planetary magnetospheres, all emit radiation that shifts and pulses. But those sources are far away. Their patterns are well studied and logged in catalogues decades deep. This wasn't one of them. The signature matched nothing known, and it came directly from the region where 3I Atlas was expected, adjusted for its new trajectory just hours prior. What made this so unsettling wasn't the power of the signal. It was faint, but its precision. In natural systems, radio emissions drift. They smear across the spectrum due to velocity, spin, or magnetic turbulence. Even plasma from comets produces erratic spikes that fade in seconds or blur into white noise. But this pattern didn't drift. It held still. It repeated, and then it stopped, cleanly, like a transmission that ended on purpose. Astronomers at the observatory scrambled to verify. Multiple dishes were retasked. The signal didn't return, not once. But that silence may be even more meaningful than the burst itself. Because for over 6 hours afterward, deep space listening stations across multiple facilities in Australia, Chile, and Italy pointed dishes toward the object. They heard nothing, not even background scatter from known cometary volatiles. The radio spectrum near 3I Atlas went quiet, not low, but absent. This wasn't just a comet without a tail, it was an object without expected emissions, except for the one brief burst. And the signal it gave us wasn't what a comet says, it was what a machine might. No one is claiming communication. There is no message, no content, no encryption. But if you build spacecraft, if you design probes, if you understand how machines talk across vacuum, then you recognize what repeating, timed bursts in narrow radio bands represent. They represent control, status, synchronization, a heartbeat. So what do you call a comet that pulses once then disappears? What do you say when something speaks? Not with language, but with silence and rhythm. You listen, you wait. And you wonder what comes next. There is a certain expectation in solar physics, a principle that holds true across every natural interaction we've ever observed near the Sun. Nothing resists the solar wind. Every comet, asteroid, probe, or particle that moves through the Sun's influence eventually yields to its breath. The solar wind is not a gentle breeze, it's a continuous stream of charged particles, electrons, protons, and magnetic fields, blasting outward from the solar corona at hundreds of kilometers per second. It sculpts comet tails, strips planetary atmospheres, and even alters the trajectory of interstellar objects. But 3I Atlas didn't yield. In fact, it didn't react at all. At 2:43 UTC on December 30th, the Parker Solar Probe, stationed just under 0.3 astronomical units from the Sun, passed through a region of solar wind turbulence. The probe is designed to record the tiniest fluctuations in this stream, variations in density, magnetic flux, and directional flow. That morning it detected something strange. As the Sun's wind swept across its usual arc, a narrow gap appeared, a corridor where particle density abruptly dropped. For a span of just 17 minutes the flow was interrupted, not by an object, not by a flare, but by a sudden absence of interaction. The path of the anomaly pointed outward, directly along the new trajectory of 3I Atlas. That raised a question. Had the object passed through this corridor just moments earlier? The answer came not from Parker, but from Earth. At the same moment, a coordinated magnetospheric monitoring system, involving ground stations in Norway, Antarctica, and eastern Russia, logged a minor but synchronized deflection in the Earth's magnetic field. It wasn't major, barely measurable, but it happened at the same solar angle, one aligned with where 3I Atlas would have been, had it created some form of electromagnetic disruption. Still, the data remained circumstantial until the next layer emerged. Just before dawn, ESA's solar orbiter confirmed what the Parker data hinted at. The object had not been pushed by the solar wind. It had moved through it, without drag. In physical terms, this is nearly impossible. Cometary bodies with active jets and wide comas are especially vulnerable to solar wind. Their tails bend precisely because the solar particles push their outcast material away. Dust particles, ions, and plasma respond like smoke in a storm. They scatter, they stretch, but not this time. Images from the heliospheric imager on the orbiter showed the surrounding particles bending around the projected space where 3I Atlas should have been. Like a rock in a stream. Like an obstacle, not a passive body. This is the kind of behavior you would expect from something with magnetic shielding, from a spacecraft using plasma sheaths to deflect radiation, or from a structure dense enough and ordered enough to resist solar interference. Natural comets can't do that. Their comas are too diffuse, their tails too fragile. Even their nuclei, often loosely bound collections of rubble, lack the structural integrity to ignore radiation pressure. They disintegrate, they veer. But 3I Atlas remained steady. The resistance to solar wind wasn't chaotic, it wasn't reactive, it was controlled, as if the object anticipated the environment and compensated for it. No spinning, no visible expulsion, no jet alignment to explain the force, just stable movement through an unstable medium, and that breaks the model. Either we're watching a comet that carries material properties no natural object should possess, or we're seeing the signature of something else, something engineered to move in silence, stability, and defiance of solar physics, because what doesn't yield to the sun usually doesn't belong in the solar system at all. The chemistry of comets isn't supposed to change suddenly, at least not like this. For months, since its initial detection in July, 3I Atlas has been classified, cautiously but consistently, as a carbon dioxide dominant object. That alone made it rare. Most comets, even those from the distant Oort cloud, show water as their primary volatile. Carbon dioxide is present, of course, but it's a trace component, a secondary actor in the performance of solar heating. 3I Atlas broke that rule from the start. The James Webb Space Telescope confirmed early on that the coma was disproportionately saturated with carbon-based molecules. CO2 outgassed at a ratio nearly 8:1 over water vapour, a finding that puzzled even the most experienced astrochemists. Some attributed it to the object's place of origin, a frozen system far colder than our own. Others suspected surface alteration by cosmic rays during its long interstellar drift. But there was no doubt this was a carbon-rich comet. Until now. On the morning of December the 30th, a new batch of spectral data came in from the IRTF, NASA's infrared telescope facility in Hawaii. It had been scanning the object in quiet intervals for over a week. Most of the time, it saw the same thing, a relatively static coma, with carbon dioxide emission lines outshining all others. But something shifted overnight. The carbon signature dropped, not to zero, but enough to be statistically impossible under the expected outgassing model. Simultaneously, water vapour lines increased, significantly. Not over hours, not gradually, almost instantly. When plotted on a time series graph, the inversion looks like a cross. CO2 emission levels slope downward at the exact moment H2O lines rise. The inflection point is sharp, not staggered. It happened between two scans, a window of just 43 minutes. That is not natural behaviour. Volatile release from a comet is a function of heat. Ice sublimates, gases escape, and the ratios change slowly as different layers are exposed. A typical comet might show gradual variation as it spins, as sunlight heats different regions, or as internal pockets rupture, but not an inversion. And certainly not a clean one. To explain this, some scientists proposed a rotation event, a sudden flip in orientation that exposed a new side rich in water ice. But the light curve showed no corresponding torque, no shift in brightness, no irregularity in spin. Others suggested event seal, a collapse of one region and the activation of another. But again, the coma remained symmetrical. The dust content was stable. There was no evidence of structural disruption. Then came a hypothesis that drew silence: internal reconfiguration. In engineering terms, that means something inside changed. That pressure or thermal conditions caused an internal redistribution of materials, like systems switching over. The speculation got louder behind closed doors. What if the object stores its volatiles? What if it can regulate which ones it releases? If that's true, then we're not observing sublimation. We're observing selection. This would make 3I Atlas the first known celestial object to change its chemical output without a change in environment, without new heat, without proximity shifts. It simply decided, or was triggered, to switch emissions, from carbon to water, from the unfamiliar to the familiar, from alien to something that looks just enough like what we expect to keep us unsure. And maybe that's the point, because if it started with exotic chemistry and now moves towards standard signatures, what's it trying to blend in with? What story is it rewriting, not in movement, but in molecules? Reflectivity doesn't just change without a reason. Every celestial object has an albedo, the measure of how much light it reflects. It's a fingerprint of surface composition, texture, angle, and exposure. For most comets, albedo is low. They're dark, carbon-coated, dust-strewn objects, reflecting very little light, often less than 5% of what strikes them. Their brightness in the sky comes from glowing gas and scattered dust, not reflective surfaces. 3I Atlas, until now, had followed that script. Its baseline reflectivity was consistent, low, diffuse, natural. But on the night of December 30th, that changed. At 03:22 UTC, an unexpected spike was observed across multiple platforms, from NASA's Wide Field Infrared Survey Explorer to ground-based telescopes in Chile and Spain. The light from 3I Atlas suddenly increased, not drastically, but sharply, measurably by over 20%. This kind of brightening isn't unheard of. Comets can flare when jets erupt or when volatile layers burst. But these flares are usually accompanied by dust, messy halos of material scattering sunlight and confusing readings. This wasn't messy. This was clean. The light intensified, not from the edges of the coma, but from the object's core. The spike was centralized, compact and symmetrical. Instruments tuned to track rotation expected the object's spin to reveal a new, possibly reflective surface turning into view. But no such rotation occurred. The axis remained constant. The rate of spin didn't change. There was no wobble, no precession, no venting force that might suggest a tumble. The object got brighter without moving, and then, after exactly 12 minutes, it faded. The return to baseline was as smooth as the climb. No sputtering, no flare residue, just a calm descent back to the object's original luminosity. As though a switch had been flipped off. Astronomers call this a non-photometric anomaly, when the brightness of an object changes without accompanying motion, chemical outgassing, or surface eruption. But even that term doesn't do justice to what was seen here, because this wasn't a fade due to orientation. It wasn't caused by distance or perspective or atmospheric distortion. This happened across observatories, across instruments, and across wavelengths. One signal, one flash, then stillness again. The only phenomena that mimic this kind of pattern are artificial satellites, when solar panels catch the sun and reflect light directly at Earth in what's called a specular glint. It's a signature well known to sky watchers who accidentally capture flare-offs from Starlink arrays or defunct upper stage boosters in low orbit. But 3I Atlas is not in orbit. It's far beyond Earth, moving along an outbound interstellar arc with no known reflective panels, no surface geometry that could justify specular behavior, at least not naturally. And this isn't the first time it's happened. A similar brief flash occurred on November 3rd. At the time, it was dismissed as solar interference or an artifact in the imaging array. But in light of the December 30th event, researchers are now revisiting that data, and others like it, to determine if this is a recurring pattern. If it is, then we're looking at more than a surface. We may be looking at a mechanism, because reflectivity doesn't spike for no reason. It doesn't emerge from dust. It doesn't organize itself into a timed pulse without some internal trigger, especially not in deep space, where sunlight is weak and resources are few. And if 3I Atlas can adjust its brightness without rotating, it means something on or within it knows where the sun is and how to respond to it. That's not normal comet behavior. That's precision. Movement always leaves a trace. In the cold vacuum of space, even the subtlest shift of a comet, a jet, a flare, a microfragment bursting from beneath the surface, creates ripples. Not sound, but echoes in data. Light curves wobble, spectral signatures shift. Dust scatters and refracts. Nothing moves in silence. And yet, on the night of December 30th, 3I Atlas moved, and left nothing. At 04:14 UTC, a coordinated orbital tracking sequence involving three of the world's most precise facilities: the Indian Mount Abu Infrared Observatory, the Catalina Sky Survey, and ESA's Gaia DR2 positional pipeline, registered a deviation, small, consistent, directional. The object had accelerated, again. This wasn't the first time. Since its discovery, 3I Atlas had demonstrated minor but persistent non-gravitational accelerations. These were often attributed to standard cometary outgassing, uneven sublimation, releasing jets of vapor and particles that push the object subtly off course. It's a common explanation, and most of the time a sufficient one, but not this time, because this time there were no signatures, no energy release, no rise in volatile emission, no thermal bloom, no optical haze, no coma fluctuation. It just moved, in a way that nothing should. To understand why this is so strange, you need to know what scientists expect to see when an object changes velocity in space. The fundamentals are simple. For every action, there is an equal and opposite reaction. Newton doesn't leave room for negotiation. So if 3i Atlas pushed itself along a new heading, even by a fraction of a degree, something must have pushed back. But there was no pushback, no expulsion, no momentum signature that could account for the change, no wobble in the rotational axis, no asymmetry in the coma, nothing measurable in dust distribution, nothing in ultraviolet, nothing in the X-band, just clean movement. Even artificial satellites can't do this silently. When they fire thrusters or adjust panels, we see it. When probes change course, their exhaust vents or radiative shifts are detectable across sensor arrays. Engineers design them that way because space is too precise to allow unseen errors. But 3i Atlas seems to move without revealing the cost of that movement. For scientists tracking the event, this isn't just odd, it's terrifying. Because if an object can adjust its heading, maintain vector stability, and suppress the byproducts of that shift, it suggests one of two things. Either it possesses a propulsion mechanism we don't understand, or it isn't propelling itself at all. Instead, it might be interacting with something around it, manipulating forces we haven't modelled. Gravitational harmonics, electromagnetic pressure gradients, unseen particle flows. Some theorists call this passive vectoring. Not movement in the traditional sense, but the redirection of external forces, guiding photons, solar wind, or radiation pressure in ways that produce real acceleration without jets, fuel, or thermal release. To do that, a structure must be sensitive, aware of its orientation, capable of absorbing force on one side, deflecting it on another, and timing each reaction with incredible precision. That's not how comets behave. They burst, they crumble, they leave trails. Their movement is messy, reactive, noisy, a byproduct of ice, heat, and pressure. But this wasn't messy. It was clean, linear, silent. It was motion without footprint. And in the world of astrophysics, that's not just rare. That's almost impossible. The first time it appeared, it wasn't even clear what it was. High-altitude observations from Chile's Cerro Tololo and infrared sweeps from the VLT in Paranal had flagged something faint and faintly reversed. A stream of particulate matter or energy that seemed to radiate toward the sun, not away from it. At first, analysts assumed a sensor glitch or a temporary distortion from solar interference. But then came the confirmations. Independent amateur astronomers from Italy, Argentina, and Taiwan all caught the same spectral signature, a faint, elongated emission stretching sunward from 3i Atlas, directly against the solar wind. It defied the usual physics. Cometary behavior has long been defined by dual tails, one ion, one dust, both trailing behind due to solar radiation pressure and solar wind. An anti-tail is a known but rare illusion, usually a perspective effect, but this wasn't that. This anti-tail grew longer the closer 3i Atlas approached Earth. And unlike traditional comets, the alignment didn't shift with viewing angle. It stayed locked in the same orientation, regardless of where Earth orbited relative to the object. That singular fixedness was the first real clue. This wasn't illusion. It was structure. NASA's Heliophysics division rerouted one of its minor L1 satellites to focus exclusively on the region surrounding 3i Atlas. The first enhanced image was inconclusive. The second, taken on a multispectrum pass, showed charged particle dispersion, mostly ionized carbon and silicon, emanating from the anti-tail in a regulated pulse. Not an explosion, not scatter, a pulse, the frequency, every 61 seconds. That's a metronome, said one analyst at the Jet Propulsion Laboratory. That's not random ejection. The idea gained traction that 3i Atlas wasn't just emitting material, it was doing so rhythmically, perhaps intentionally. The anti-tail may not have been a remnant or a byproduct. It could have been a communication array, or even a guidance stabilizer, a way to anchor itself against the shifting gravitational tides of nearby planets. But that theory raised more questions than answers. What sort of natural object, or artificial construct, needed a stabilizer in deep space? As the anti-tail lengthened, something even more bizarre happened. The standard forward momentum of cometary debris was reversed. The particles weren't being pushed by radiation pressure, they were resisting it. Observatories captured dust grains moving inward, toward 3i Atlas's core, in direct opposition to both its motion and the solar wind. One astrophysicist described the effect as like watching sand flow uphill against gravity. On December 5th, the Space Weather Prediction Center flagged a low-level geomagnetic anomaly, not enough to impact satellites, but enough to twist radio frequencies near the 40 MHz range. The cause? A slight ripple detected across the Earth's magnetosphere, aligned with the 61-second pulse rate of 3I Atlas's anti-tail. That meant the tail was not just visible, it was energetic. It was influencing systems across millions of kilometers, and worse, it was doing so with precision. One unspoken possibility crept into late-night meetings at the European Southern Observatory and MIT's Kavli Institute. What if the anti-tail wasn't responding to the sun, but responding to us? Some began testing for frequency harmonics that matched Earth-based radio emissions. A few researchers claimed to find correlations. No one went public. The fear of sensationalism or misinterpretation loomed too large. Yet behind the scenes, the question continued to grow. Why was 3I Atlas, this supposed interstellar object, creating a symmetrical stream that behaved like an antenna? Why was it locked in a countersolar position? And what was it sending, if anything at all? By the time the anti-tail crossed the 400,000-kilometre threshold in visible spread, its silhouette had begun warping. Instead of a singular beam, it was forming segments, like vertebrae, each glowing faintly in a progression that followed the Fibonacci pattern. It was no longer just a feature, it was a signal. Beneath the invisible frontier known as the solar system's ice line, a region beyond which water and volatile compounds can remain frozen, a different kind of silence rules. It's not the absence of sound, but the suppression of motion. The gravitational tensions are stable, the thermal variations minimal, and the solar influence drops to a whisper. This is the realm where ancient objects coast unbothered, and where modern observation tools struggle to draw clear lines between background noise and meaningful signals. It was in this region, beyond the frost boundary but not yet in the true outer system, that a new discrepancy emerged. At precisely 0449 UTC, an array of sensors aboard ESA's JUICE probe began returning low-amplitude flux signatures from an unexpected direction. These weren't the chaotic, short-lived bursts typical of background radiation or solar interference. They were rhythmic, repeating, echoing in a fixed pattern that coincided with the slow, orbital sweep of a smaller body, a fragment believed to be trailing behind 3I Atlas since its encounter with Earth. But it wasn't just trailing anymore. Using synthetic aperture radar, the JUICE team layered time delay mapping over the region and noticed a strange correlation. The signals weren't just ambient emissions from a passive object. They were being refracted, bent in ways that implied spatial anomalies. Denser than expected mass concentrations were altering the propagation of energy through what should have been vacuum. It appeared as though there were pockets of something, perhaps frozen compounds, perhaps structured voids, forming a veil beneath the object. NASA's Deep Space Network in Canberra ran a parallel model using LiDAR cross-sectioning and confirmed the distortion. There was a shadow structure, and that changed everything. Because in celestial mechanics, shadow doesn't mean absence. It suggests interference, an obstacle. Something interacting with the surrounding field, gravitationally or electromagnetically, to create a measurable difference between what should be there and what is. The data was subtle, but consistent. Every 3 hours and 46 minutes the refracted signature repeated. Not a pulse, but a silhouette. The shape was consistent across 2 orbital passes, and it was angular. That angularity, the presence of defined edges, is what set off the alarms. Most naturally forming cometary debris presents as diffuse clouds, chaotic in outline. But this wasn't a smudge, it was geometric, the kind of geometry that implies either crystalline formation or intentional design. Engineers at the Applied Physics Laboratory began constructing spectral density maps of the interference pattern. The results shocked even the most skeptical analysts. The outline resembled a tetrahedral array, a configuration known for its structural efficiency in both biology and aerospace engineering. Could nature have formed something this ordered? Possibly. But the probability curve dropped precipitously with each hour of observation. What made the situation more disturbing was that these shadows remained just beneath the observable boundary. They never fully revealed themselves, always in profile, never in full orientation. It was as if they were hiding not from sight but from interpretation. Back on Earth, The silence among the top-level analysts was more telling than any published paper. No one wanted to go on record. Not yet. But in private calls and secure signal exchanges, one phrase kept repeating, "We're not alone in the field," and that changed the mission posture from passive monitoring to active preparation. Because if the structure beneath the ice line wasn't natural, or even if it was, its alignment, behaviour, and persistence meant that the solar system was no longer just hosting a visitor. It might be hosting a beacon, or worse, a door. It wasn't just light or motion anymore. By the early morning of December 30th, the phenomena surrounding 3I Atlas began shifting into another dimension, one that had less to do with trajectory and more to do with resonance. Space weather monitors across the globe, from the Arctic Circle to the southernmost nodes in Tasmania, started picking up disturbances in the Earth's magnetic field. Not spikes, not flares, but rhythmic pulses, subtle, harmonic, and strangely ordered. At first, these pulses were thought to be artifacts, internal system errors caused by the recent solar fluctuations. But by 0341 UTC, that assumption was dropped. The rhythm was repeating every 97 seconds, and it was being picked up by at least 6 independent observatories, all separated by thousands of kilometers. These weren't isolated sensor glitches. They were synchronized signatures. The strangest part. These magnetic pulses weren't originating from the sun. They weren't being driven by solar wind, coronal mass ejections, or even residual effects from the heliosphere. The signal was coming from space, specifically the region directly behind Earth's orbital shadow, aligned with the corridor where 3I Atlas had recently passed. That realization rewrote the entire conversation. It meant the object wasn't just influencing its own trajectory. It was leaving behind a wake, an aftershock of electromagnetic resonance that Earth's field was now responding to. Like a tuning fork being struck in vacuum, the planet itself was vibrating to a signal it didn't send. This effect wasn't just theoretical. Pilots flying transpolar routes began reporting strange compass drift. Minor at first, but consistent. Some recorded instances where altimeters or navigation systems briefly lost sync, then realigned as if recalibrating to a new invisible standard. Commercial satellites reported micro-adjustments in their orientation protocols, forcing mission controllers to increase the frequency of manual corrections. At ground level, most of the population remained unaware. These were soft, subtle effects, barely enough to register on public radar. But in deep space communications labs, the shift was triggering a quiet scramble. Engineers began isolating the signal and feeding it into frequency mapping software. The results were chilling. This was not random noise. The waveform being observed followed a narrow band harmonic structure, almost musical in its decay. A slight rise, a shallow trough, then a sharp compression. It mirrored a pattern known in acoustics as a chirp signal, something often used in radar and sonar to probe complex environments. But this signal wasn't probing Earth. It was echoing backward, reverberating from the path 3I Atlas had carved through the near-Earth magnetic region. One theory started taking root. What if the comet, or whatever it had become, wasn't just leaving debris behind, but something more abstract, a residual field, a calibration layer? Some researchers referred to it as a magnetic ghost, a lingering pattern left in the very structure of space itself. Not particles, not heat, but memory. A temporary imprint that told any intelligent observer, "I was here, I passed this way." It might sound fantastical, but the observational consistency forced analysts to accept it as plausible. The field line resonances began to vary subtly as Earth rotated, suggesting that this wasn't a fixed broadcast but a moving interaction. The Earth's magnetic field was responding dynamically, as if in conversation, and perhaps in a way it was. For decades, magnetic field lines have been seen as passive guides, shaped by the Earth's iron core and the solar wind. But now something foreign had intersected those lines, left its mark, whispered through frequencies that only instruments could detect. The implications weren't yet fully understood. But one thing was certain. 3I Atlas had not simply passed near Earth. It had altered the environment it left behind, not with collision, not with radiation, but with resonance. And that resonance was still echoing, hours after the object had moved on. As dawn broke on December 30th, a quiet tension rippled through the astrophysical community. The signals were still coming, and no one could yet say why. There was a strange quiet after the spike. When NASA's Deep Space Network logged the last detectable transmission from the region between 3I Atlas and the Swan object, the immediate instinct was to recheck the instruments. Had the signal just dropped? Had solar interference drowned it out? Or worse, had something terminated it? But as teams sifted through the raw data, it became clear. The signal hadn't faded, it had stopped, and the timing was suspicious. Just 6 minutes before the cutoff, the Swan object had initiated a sequence that resembled a course adjustment. Not a violent maneuver, but something more elegant. Its trajectory didn't shift radically, but its rotational pattern did. Using high-frame interferometric overlays from SOHO and TESS, analysts noticed a tightening spiral. Something within the object, or around it, was reorienting. And right after that, silence. This raised a profound question. What if the communication wasn't disrupted by accident? What if the pause itself was the signal? Some experts at the European Southern Observatory began modelling the signal pattern using pause interval logic. This wasn't Morse code or binary, it was rhythm. Like a drummer in space using pulses of light and gravitic oscillations, with silence as punctuation. If true, this meant that the signal ending was a deliberate event, a punctuation mark in a sentence we didn't know how to read. Meanwhile, something even stranger emerged. Over a span of 48 minutes after the silence, Earth's ionospheric sensors detected an anomalous dip in high-frequency propagation. At first, the cause was thought to be solar, perhaps a CME or a minor flare, but the sun was calm, no flares, no storms. And yet, over North Africa and parts of the South Pacific, radio operators reported temporary blackouts on civilian bands, mostly in the 10 to 14 MHz range. Then came a second anomaly. High-orbit satellites, including NOAA's GOES series and ESA's Meteosat constellation, began experiencing brief phase jitter. Normally this wouldn't be notable, but the effect was simultaneous and global, not directional, not sourced from a single geographic point. It was as if space itself had flexed slightly, a tiny synchronized contraction across multiple latitudes. No one could link this directly to the signal, but the timing was tight. The silence between 3I Atlas and the Swan object wasn't just a data void, it was followed by a physical echo, not light, not noise, but something tactile. Something that pressed against systems not meant to detect pressure. Physicists from the University of Tokyo speculated it might be a form of low-frequency space resonance, a ripple not unlike gravitational waves, but shallower and broader. Not enough to trigger LIGO or Virgo, but enough to shift the timing of onboard atomic clocks by microseconds, enough to make precision equipment feel off for just a moment. Others suggested it was psychological. Several mission teams, across 4 time zones, filed internal notes about staff fatigue, disorientation, and a strange emotional flatness in the hours following the silence. It wasn't fear, it wasn't panic, just hollowness. Like something had left the room, like something had just watched us and then looked away. This was the terrifying idea that began to circulate behind closed doors, that the silence wasn't just the end of a signal, it was the start of observation. And in that moment, Earth wasn't the one doing the watching anymore. There had been faint signals before, brief fluctuations in magnetometer readings, small blips in auroral sensors, isolated anomalies that were easy to dismiss. But as 3I Atlas and the Swan object locked into their synchronized path, the reaction from Earth's magnetosphere was no longer faint, it was visible, measurable, and above all persistent. At exactly 03:03 UTC, every magnetic observatory across the globe recorded an unusual pattern. The wave wasn't strong enough to be considered a geomagnetic storm, nor did it follow the typical structure of a solar-triggered disturbance, but it had form, a signature, a rhythm. It began as a soft pulse, low-frequency oscillations that didn't match any known solar or terrestrial origin. These weren't the usual coronal mass ejection aftershocks, or the kind of ionospheric reverberations caused by lightning or atmospheric gravity waves. The frequency sat in the subhertz range, just below the threshold of human perception, yet distinct within the electromagnetic spectrum. It pulsed in intervals, 4 seconds on, 4 seconds off, repeating. At first, most thought it was another coincidence, an overlapping solar echo or a product of natural terrestrial noise. But when the signals were overlaid with satellite trajectories and matched with the real-time orientation shifts of both 3I Atlas and SWAN, a pattern emerged. The pulsing wasn't random, it was synchronized with the angular rotations of both objects. Every time 3I Atlas tilted, subtly adjusting its axis, Earth's magnetosphere reacted, not with force, but with response, a kind of electromagnetic echo, almost as if Earth itself were being pinged, or answering back. Auroral activity began to spike, but not in the usual regions. Instead of bright displays near the poles, faint glows were recorded much farther south and north than expected. Argentina, Australia, parts of Spain and Japan all saw traces of violet and blue waves flickering across the sky. These weren't the green bands usually associated with solar particles colliding with atmospheric molecules. This was something else entirely. Cooler in hue, quieter in frequency, a kind of atmospheric whisper. NASA's Goddard Space Flight Center and ESA's Solar Orbiter teams both confirmed the source of the change wasn't the sun. There were no new flares, no recent CMEs. The solar wind remained consistent. Whatever was creating the reaction on Earth was coming from deep space, or more specifically, from the synchronized motion of two inbound objects whose behaviors now defied every assumption. Some began to theorize that the signal wasn't just electromagnetic, it was harmonic. Researchers from Japan's Institute for Space-Earth Environmental Research used Fourier transformation models to isolate the waveforms. The result was stunning, a mathematical scale built on the Fibonacci sequence. The oscillations followed intervals of 13, 21, 34, then silence, and then it repeated. This was not natural interference. This was engineered rhythm. Questions began to flood scientific forums and classified defense networks. Was this an attempt at communication? Were 3I Atlas and the SWAN object using gravitational or magnetic fields as a medium to interact with Earth? Or worse, were they merely triggering a passive system already embedded in our planet, something we had never known existed? For some, it was a stunning moment of cosmic connection, a sign that we were part of a broader network of celestial awareness. For others, it was the first undeniable evidence that the objects were interacting not just with each other, but with us. The quiet tension spread. Monitoring stations lengthened their observation shifts. Deep space radar dishes were retasked. AI models were rewritten to interpret the waveforms as potential linguistic or informational packets. The Earth had been touched, not by light or matter, but by frequency, and it had responded. By the time the electromagnetic echoes reached Earth's listening stations, a strange consensus had already formed across multiple observatories. Something was trying to communicate, but this time the data didn't originate from 3I Atlas alone. It came from two distinct sources. One was the primary body, the object humanity had been tracking for months. The other was the SWAN object, once dismissed as a coincidental background anomaly. Now it was transmitting patterns that could no longer be explained away. It started as a shared pulse. At exactly 1:02 UTC, both objects emitted matching frequency bands, narrow, high-intensity bursts that aligned perfectly in time but were slightly offset in waveform. On their own, they might have been seen as background noise or energetic interference, but when researchers at ESA's S-Track network layered the data, something impossible happened. The pulses locked into a harmonic rhythm. One tone, followed by a pause, then a responding tone altered slightly in pitch, then another, then another. What emerged wasn't just a pattern, it was structure, a call and response. A binary-like exchange, not language in the conventional sense, but a form of interaction that obeyed rules, repetition, alternation, consistent timing. In music theory, the sequence resembled a counterpoint, where one melody mirrors another but evolves independently. In physics, it mirrored entangled systems, but these weren't particles. They were massive celestial bodies, millions of kilometers apart, pulsing energy into space as if locked in conversation. NASA's JPL team ran comparative models using machine learning to simulate random burst patterns. The probability of these two sequences aligning unintentionally? Less than 1 in 400 billion, which led to an unsettling conclusion across research teams. They weren't just aware of each other, they were interacting. Even more disturbing was what followed next. After 12 iterations of their exchange, both objects fell silent, for exactly 33 minutes. Then, simultaneously, both emitted a different tone. This one wasn't rhythmic, it was sustained, a drawn-out frequency, low and vibrating, that bled into the plasma fields of the outer heliosphere. Satellites orbiting Mars picked up minor EM distortions. The JUICE probe near Ganymede recorded gravitational wobbles just 0.2% off its predicted arc. Even Voyager 2, still active at the edge of interstellar space, showed telemetry anomalies that coincided with the burst. The alignment was too precise. Whatever these objects were doing, they were no longer acting as independent travelers. They had entered what astrophysicists reluctantly called intentional resonance. One astrophysicist at the University of Tokyo phrased it more bluntly. They're not from the same origin, but they've found each other, and now they're syncing. The implications rippled across every scientific discipline. If these bodies were communicating, even in the broadest energetic sense, it meant they possessed not just sensors, but predictive capabilities, a way to model their surroundings, detect each other, and respond across astronomical distances with almost no delay. That kind of behavior required more than random interaction. It required memory. And it required some form of decision-making. But the most jarring discovery came when researchers applied audio spectrum analysis to the sustained frequency burst. Under careful enhancement, they uncovered modulation bands hidden in the tail of the signal, not static, not random. They followed the Fibonacci sequence, again, 13, 21, 34, 55. A scientist at the Max Planck Institute simply closed her laptop when the results came in. "It's not just math," she whispered, "it's intention." And somewhere behind the data, the deeper question loomed. Not what the objects were saying to each other, but what they were preparing for. At first, the changes were subtle. Meteorologists across the northern hemisphere began noticing irregularities in the upper atmosphere, specifically in the polar stratospheric wind patterns that define the polar vortex. Normally, the vortex is a stable feature of winter, a ring of cold, fast-moving air that circles the Arctic and helps regulate jet streams. But something had shifted. Satellite data from the European Space Agency's Aeolus wind profiler showed sharp deviations, spikes in velocity followed by sudden collapses in shear zones. These weren't natural fluctuations caused by seasonal transitions or El Niño effects. They were abrupt, almost like shock waves, and they began syncing with the gravitational intervals logged by space observatories tracking 3I Atlas. At 05:20 UTC, the first serious flare-up was recorded above northern Greenland. The polar jet fractured into two arms, creating a low-pressure sink that descended into the mid-troposphere. In response, Arctic temperatures plummeted to -61 degrees Celsius, while sudden warm air masses were simultaneously pulled into Siberia. This kind of atmospheric tug-of-war isn't unheard of, but the speed, symmetry, and repeatability were. And the underlying force wasn't terrestrial. NOAA's high-altitude weather balloons detected pressure waves moving vertically, originating not from Earth's surface, but from above the stratosphere. These waves compressed and expanded in patterns that eerily mirrored the electromagnetic fluctuations detected near the object's tail. It was as if the approach of 3I Atlas was subtly massaging the Earth's atmospheric boundaries, pushing the limits of what we thought was causally linked. And then, the flare-ups began to oscillate in harmony. Within 24 hours, both the North American and Eurasian vortex structures showed mirror disturbances. Each vortex experienced abrupt widening, then tightening, causing extreme shifts in wind direction. Commercial flight paths were forced to reroute over Canada and Russia, as upper atmospheric turbulence became too dangerous to navigate. Pilots described walls of wind appearing mid-air, turbulence that had no warning signatures on radar. It was atmospheric behavior that suggested a system under external stress, being stretched beyond design. What unsettled atmospheric physicists most was the energy signature. Typically, polar vortex activity is a closed-loop response, driven by surface temperatures, solar radiation, and pressure gradients. But this time, the energy profile had an added layer, Observatories in Norway and Alaska recorded ultra-low frequency signals, ranging from Drusen to Zorsku 5 Hz, emanating from the polar regions just before each flare-up. These are frequencies often associated with deep Earth phenomena like tectonic pressure shifts or glacial shears, but there had been no quakes. No movement beneath. These signals were descending, not rising. This led researchers to consider a terrifying hypothesis, that the interactions in the upper atmosphere weren't just meteorological or magnetic, they were vibrational. That Earth's crust and sky were both responding to the same cosmic pressure, and that 3I Atlas, perhaps through resonance, perhaps through simple mass displacement, was pulsing those responses into motion. By the end of that week, auroras began appearing far outside their normal latitudes. From Montana to central France, purple and crimson curtains rippled across the night skies. But they came with something else: static build-up. Radio towers on multiple continents reported strange capacitance surges, not enough to damage equipment, but enough to suggest an accumulation of charge, like the whole planet was holding its breath. These polar vortex flare-ups were no longer just meteorological curiosities, they were symptoms, not of weather, but of warning. The atmosphere wasn't just changing, it was reacting, and the trigger, whatever it was still approaching. What happened next didn't come from above, but from beneath our feet. On the morning of December 22nd, while most of the focus remained locked on 3I Atlas and its approaching alignment, a sudden tremor disrupted the deep silence beneath the Pacific tectonic ridge. It wasn't a major earthquake, not by conventional standards, but it was strange, too shallow for subduction zone activity, too symmetrical in its waveform. And perhaps most unsettling of all, it mirrored a seismic ripple that had been recorded exactly 21 minutes earlier in the Arctic Basin, just off the coast of Greenland. Geologists were the first to notice the echo pattern. By comparing timestamps and phase data from different monitoring stations, they reconstructed the signature. The pulse wasn't random, it followed a rhythm. It wasn't the chaotic release of tectonic stress, nor the sharp violence of a volcanic fracture. Instead, it hummed. A low, persistent oscillation that moved laterally, almost like sonar, or a ping. That's when the comparison started. Archived seismograph data from 2004, 1997 and 1983, 3 known periods of unexplained harmonic tremors, were pulled up and layered against this new December 22nd event. The match wasn't just close, it was almost exact. Identical frequency envelopes, identical decay curves, as if the same signal was being broadcast again, decades apart, and always in the build-up to an unusual atmospheric or magnetic event. But this time, there was one critical difference. It coincided with 3I Atlas. Satellite gravimetry from ESA's Goki mission, though outdated, was used as a comparative baseline. Modern equivalents, especially the Grace Follow-On constellation, provided real-time updates of subtle shifts in Earth's mass distribution. And on that morning, as the seismic wave spread, Grace registered a strange anomaly beneath the ocean floor. A sudden, localized drop in gravitational density. Not enough to suggest collapse or magma movement, but enough to suggest displacement, as if something massive had passed through, or awakened. Was it geological? Possibly. But the symmetry of the signal had another possibility: resonance. And that brought new voices into the conversation. Acoustic physicists and planetary scientists who specialize in seismic mapping and lithospheric acoustics. Their analysis revealed that the signal's waveform was best explained not as an origin pulse, but as a response, a reflection. In other words, something had bounced off something else deep below us, something that didn't fit known geologic layers, something rigid but not natural, something positioned precisely to reflect the wavelength and return it on an identical phase shift 21 minutes later, halfway around the world. Some at NASA began calling it the shell theory, the idea that there may be ancient unknown strata beneath Earth's crust that only respond to very specific acoustic conditions. Others went further, suggesting that if 3I Atlas is indeed emitting directional frequencies toward Earth, perhaps the planet itself is beginning to resonate in places we didn't know were capable of resonance. What added to the mystery was the timing. Every previous ping, from 1983 to 2004, occurred during moments of cosmic alignment, planetary conjunctions, deep solar minima, and now, as 3i Atlas was rapidly aligning with Earth and Swan in a harmonic triangle, the same echo had returned. But it wasn't just about the sound. Local wildlife across the Pacific Basin, whales, dolphins, even colonies of deep-sea bioluminescent creatures, suddenly changed behaviour. Pods redirected migration paths. Signal calls increased in complexity. In some regions, entire ecosystems went silent for hours. It was as if something primal had been felt, not heard. For geologists and astronomers alike, the takeaway was clear. Earth was responding. Not in violent defiance, but in some deeper frequency. Like a tuning fork being struck from a great distance. Something was reaching in, or calling out. And beneath the Pacific, Earth had just answered. From the earliest days of tracking 3i Atlas, astronomers were searching for patterns, regularities in spin, pulse, radiation output, and orbital deviations. And for a long time, those patterns eluded them. The object behaved too inconsistently, too unpredictably. What seemed like a spin would stop. What looked like a signature would vanish. But as the data sets deepened and the timeline stretched over months, something startling began to emerge. It wasn't that 3i Atlas was erratic, it was that its patterns operated on a scale no one had considered. Rather than hours or days, some of its repetitions spanned weeks, even months, as if it were operating on an extended clock, one not designed with human observers in mind, and now, with the object past Earth and approaching the edge of its solar system encounter, that clock seemed to be restarting. Analysts at the Max Planck Institute for Solar System Research were among the first to detect the shift. Reviewing flux and reflectivity metrics over time, they noticed that certain alignment behaviours, core wobble angles, reflectivity bands, and emission pulses were beginning to reappear. And more importantly, they were syncing up in the same order as the original detection timeline, just inverted. What happened on day 5 of observation now seemed to be echoing on day 145, but in reverse polarity, it wasn't just pattern. It was mirrored repetition. The implications were staggering. Because mirrored patterns in natural systems, especially on this scale, are exceedingly rare. Most cometary or interstellar objects don't demonstrate any meaningful cyclical signature at all, much less one that appears reflected in time. Some called it coincidence. Others, like Dr. Pavel Amarin at the Russian Academy of Sciences, weren't so sure. He published a brief but controversial preprint suggesting that information encoding might be embedded in the mirror pattern itself. It's not the frequency of the echoes that matters, he wrote, but their reversal. The order of operations has changed. This implies memory. Memory. In an object of ice, rock and plasma. But if you think about how the cosmos stores information, in magnetic fields, gravitational oscillations, radiation pulses, it wasn't entirely unthinkable. After all, stars encode their histories in light, planets in magnetospheres. Why not an interstellar traveller in mirror patterns? Even more curious was what happened when Earth's instruments began overlapping these repeated timelines. The Very Large Array in New Mexico, in conjunction with the ELISA interferometer system in Europe, detected a curious phenomenon. When mirrored patterns emerged, Earth's local instruments began to experience slight signal degradation. Not mechanical, not environmental, but constructive interference. Signals from Atlas's tail and antitail began overlapping in such a way that they produced faint but measurable resonance bands in Earth's ionosphere. Not dangerous, but real, and unlike anything seen from a natural object, as if the tail wasn't just ejecting mass, but tracing something, repeating something, leaving breadcrumbs not for others, but for itself. A form of interstellar mnemonics. Then came the solar echo. At exactly 2:07 UTC, the Soho Solar Observatory picked up a short burst of solar wind reversal, lasting only 2.2 seconds. It had happened once before, weeks earlier, when Atlas approached perihelion, and now the same pulse had returned, but reversed in waveform. It wasn't strong enough to alter anything in our solar weather systems, but it was clear enough to suggest that Atlas wasn't just repeating its own steps, it was forcing other celestial bodies to replay their reactions too. And in that moment, a new question emerged. What happens when repetition becomes recursion? Because if Atlas is remembering something, then what is it trying to relive? And what happens when it reaches the end of that cycle again? The countdown, some believe, has already restarted. For most of this journey, Earth had played the role of a passive watcher, a distant spectator to a cosmic dance playing out between interstellar anomalies, between 3I Atlas and the Swan object, between strange alignments and gravitational pulses, between theories and silences. But in the early hours of December 22nd, something subtle shifted, not in the objects themselves, but in the planet watching them. At precisely Irustu 11 AM UTC, two separate arrays, one in Tromsø, Norway and the other in Bariloche, Argentina, recorded an electromagnetic ripple across the ionosphere. This wasn't auroral in nature, nor was it atmospheric noise. Instead, the waveform bore an eerie resemblance to the low-frequency patterns previously seen in the tail-aligned emissions of 3I Atlas. But here's what made this signal different. It wasn't incoming, it was bouncing. The frequency appeared to be reflecting from the surface of Earth's own electromagnetic field, not once, but twice, as if being sampled. This reverberation pattern had not been seen in any natural space-weather interaction before. It was as if the signal had been sent not to Earth, but through Earth, testing how the planet's magnetic layers would respond. At the Goddard Space Flight Center, an emergency meeting was called just before sunrise. The team cross-referenced the event with other sensors around the globe: Australia, Kenya, Greenland. The signal was consistent. It had not entered from space. It had emerged from within Earth's own response to the objects above. This led to a chilling new hypothesis. The behavior of 3I Atlas and the Swan object was no longer isolated to their trajectories. Their interaction had begun influencing the biosphere. Subtle, soft, but definite. Even more disconcerting was the secondary effect. A new form of geomagnetic lensing was detected, not in the magnetosphere, but in the troposphere. Layers of Earth's upper atmosphere began to refract incoming sunlight differently, resulting in strange localized optical phenomena. In Chile, skywatchers reported a faint mirror effect just above the Andes, a region where light split into twin streaks without any visible cause. In northern Canada, survey drones picked up temperature anomalies 3 kilometers above the tree line, isolated hotspots that pulsed once every 27 minutes. The timing wasn't random. That same pulse duration, 27 minutes, had previously been linked to a rotation pattern observed in the Swan object's tailward structure. It no longer felt like a coincidence, and that's when something even more unusual occurred. Data from the European Space Agency's Sentinel-5P satellite revealed a temporary drop in stratospheric nitrogen dioxide levels, a sudden, sharp dip, not explained by weather patterns or volcanic influence. The drop occurred just minutes after the atmospheric pulsing reached its second peak. Researchers at MIT's Haystack Observatory reviewed the data with skepticism, but their recalibration confirmed it. Earth's own chemical signatures were briefly and measurably altered. Whether through magnetic resonance, atmospheric induction, or something not yet theorized, the presence of 3I Atlas and the Swan object was no longer purely visual or gravitational. It was environmental, and then came the final detail that cemented the turning point. For the first time since the beginning of this entire sequence, Earth-originated satellites began experiencing time drift. Not much, just microseconds, but enough to trigger safety protocols in orbital telemetry systems. The implication was hard to ignore. Earth was no longer just watching, it was now part of the equation. The story of 3I Atlas and the Swan object is far from over. If anything, this chapter may only mark the midpoint, a quiet inhale before the next revelation. What began as isolated anomalies has now spiraled into an undeniable sequence. The synchronized tail inversions, the coordinated bursts of directional plasma, the mirrored alignments traced across millions of kilometers. These are no longer mere coincidences, they are part of a system, or a signal, or something that defies our current frameworks entirely, and that realization changes everything. Across every major observatory, analysts have started to use a different kind of language, not just positional data, but behavioral descriptors. Terms like intent, response latency, and vector recalibration have entered the official documentation. In the past, that would have been dismissed as pseudoscience or speculation. Now, it's a reflection of the data. something is happening. Something vast, methodical, and perhaps aware. But the deeper question isn't just what these two objects are, it's why now? Why are they converging as Earth passes through its most exposed solar orbital region? Why do the emissions from Atlas now match the interference patterns seen in Earth's upper ionosphere? Why has the auroral activity, previously predictable, begun to show repeating shapes and non-random chromatic pulses? We don't know yet, and that's exactly why the story isn't over. What comes next may reveal whether this was all a fluke, a rare interstellar alignment of debris and plasma, or the first chapter in a new category of celestial behaviour, one that forces us to redefine what comets, space objects, or even deep time remnants of formation epochs truly are. Whatever the case, the scientific community isn't walking away, they're doubling down, expanding their observation windows, building new models, cross-referencing past interstellar transits for anything that might hint at a previous signal or pattern, because if Atlas and the Swan object are part of something larger, something that has played out before, we'll want to see it coming next time. And now that we've learned how to listen, we might. This is where we'll leave it, for now. But if you've been following this series, you already know, each discovery opens more questions than it answers. So subscribe, share this with someone who still believes space is predictable, and let me know in the comments, where are you watching from, and what time is it there? Because no matter where you are, the sky's no longer silent, and we'll be here, watching.